Okay, so today's stuff is easier. Now I need you to look up here. I'm recording during 8th period from all the questions that I've had of all the classes to make the most informative, well-questioned, thank you, well-questioned group today. Let's look at day 7 real quick, okay? Day 7, it says turn in the box project, okay? Because I told you, because I gave you those just like a class or two ago, that I changed that date to be the 28th. I'm not going to change this on the calendar because this calendar is for all classes. But you can turn this in on the 29th for 3 bonus points, okay? At the beginning of class. Like some people already did. Let me finish. Like some people have already turned in. When you turn it in, it'll be like back there underneath that thing. Please don't try to procrastinate on this, because if you miss the premise of this project, it's something that you can easily mess up. But overall, the project's fairly easy. What I'll say to that is, read the rubric. There are things even highlighted that I've gotten questions on that tell you specifically. For instance, someone asked me this, and I think the person's just overthinking, okay? The correct surface area of the inside of the open box. This third thing down. So this is just specifically talking about the inside of the open box. No cover. So imagine, like, if this is the surface area, all I have are 2 long length surface areas and then 2 small ones on the inside and then 1 full bottom. Okay? Don't try to think like the surface area is the inside of the box and the outside of the box. Okay? Because this is specifically just saying that you're looking at the surface area of the inside of the open box.
Oh, wait, so it's just the floor?
Yeah, the floor and then the walls inside. Okay, so like the inside of the house, right? You're not going to imagine like you have a box house. This is asking you to paint the inside of the house with no roof. So, no ceiling, okay?
So what's the common thing that people get wrong on that? They do that and they multiply it by 2 for the outside?
Yeah. Yeah, that's exactly, and you know that's equivalent to the same multiplied by 2, but you don't have to do it like that. It's just only the inside of the box.
So it's 3 sides of 2 ends.
So you don't just like calculate all the areas of the parts, just add them together?
Yeah, you calculate and add them together. I'm just saying, please don't account the outside of the box as surface area. The surface area, it says clearly right here, is just the inside of the box. Cool? Mm-hmm. Read it carefully, not only all of these pieces here that are on the rubric, but also read on the checkpoints or the pieces that you have as far as the examples. Like all this information will give you pieces of what's happening. Don't go off of, you can use it as an example. Remember that worksheet that I gave you that said cutting corners, and there were several examples on there. You can use that as a template, but that's not really what you're turning in. You're not turning in that chart with all of your work. You know what I mean? It's more so, it involves that kind of process, but you don't have to show all that work per se. Answer the rubric, and I know that there's a lot of us that don't like to read these rubrics. I'm going to keep telling you. If you text me, I'll say, read the rubric. Read the rubric. Unless it's a question that hasn't been addressed on the rubric. Okay? Yeah. Okay. Alright, so that is what's going to be due on those particular dates. And yes, on the calendar it says right here on the 31st, collect box projects. So I'm going to move that 1 down, and for you, you can turn it in for full credit still on February 4th.
Oh, really?
Yeah.
So I don't have to worry about it at all?
It's up to you, but if you postpone it, like again, it's not something that you want to procrastinate.
So do we use actual inches or centimeters?
Inches. It's all inches, okay?
For the real thing, we actually use it?
Alright, so let's move forward. Today's notes are dealing with something called binomial theorem. Now, don't take offense to this when I say this, and I know every time I say that people are like, oh, we're about to get offended. No. A lot of us who learn math, we try to just look at patterns. And that's the first thing that we do. Sometimes we forget the math, and all we're doing, especially on multiple choice questions, we try to find patterns. This is huge on patterns. So if you identify the pattern, this is a fairly easy day, okay? So, what is x plus y to the 0? 1. Because anything to the power of 0, write that down if you forgot it. Anything to the power of 0 is 1, except for these two things. These are not 1. Those you'll learn in calculus if you take calculus. X plus y is raised to the first power. It's just x plus y. Now watch. X plus y squared is x plus y times x plus y. But look, I'm going to do this just so you can visually see what's happening. All it is, it's a copy of the original. Okay? So down here, when it's x plus y cubed, all it is a copy of the original 3 times. And yes, the same thing down here, only it's to the power of 4, so you have a copy that is 4 times. Okay? Now watch. The ones that you should be able to do easily at this point in time by hand, and yes, you do have a quiz next class, okay? No, it does not involve the things that we are learning today, but you need to go home, turn off Netflix, turn off the video games, whatever distractions, and look at day 6 and back until the last quiz. I think it's day 3 to day 6. That'll be on this quiz that you take next time. If you didn't do too hot on this quiz, you need to do well on this other quiz, okay? All right, so going back from x plus y squared, we could do that in our head, and we could just write down the answer, okay? What would the answer be for this? Boil it out. Plus 2xy plus y squared. Nice job. So you have 2 binomials that are just boiled out, multiplied, distributed, however you want to call it. And this one particularly was on our homework that we had not too long ago. What was the name for this particular one?
Trinomial. Monomial.
So it was close to that.
Polynomial. Multiply on monomial.
No worries. No one can remember it. There was only one person out of all classes that remembered. No worries.
Quadronomial.
This is the perfect square polynomial, or trinomial. Perfect squared trinomial. Okay? Remember that on your homework?
Perfect square trinomial.
Okay. Perfect square trinomial. And the example here looks something like this. So when I fold this out, you get something like that. Cool? Alright, so 2 of these are equivalent to this. Okay, so x squared plus 2xy. And if I don't use colors and it was just black and white, this would be a confusing day for sure. So the fact that I'm using colors, that's why it's easy. Otherwise, yes, this could be confusing. Okay, so that's the first 2. And we're going to multiply it with this x plus y. Here we go. If I distribute this first x on all 3 of these terms, I would get x cubed plus 2x squared y plus xy squared. What did I do with the powers as I was multiplying these bases? I added. That's important. Write this down in your notes somewhere. If you have x squared times x cubed, it's the same as adding the powers. Okay? You might already know the next thing I'm going to show you. If you don't, you'll know it now. If you have a power raised to a power, you don't add. You would multiply here. So this is going to become x to the 6th. Understand the difference. The biggest thing that I can show you is between this power raised to a power business over here, you see a parentheses. And in math, so far, when we see parentheses, we immediately multiply. So that's a good way to distinguish which one is multiplication and which one is straight up addition. Alright, here we go. Now, if I distribute this y on all three terms, I would get x squared y, and if you find a mistake, I will give you the 100 points each time. 2xy squared and y cubed. So after I've distributed and I've gotten rid of those parentheses, I'm ready to combine like terms. Do you see any terms that are like terms? So first glance, yeah, it looks like none of them are the same. But there are some. Look at this. And they have to be exactly the same. So you could call it like the family of x squared y is 2 plus 1. So I have 3 of those guys. X squared y. Okay, yeah, and then the other one. So the other one, we have xy squared, and then 2xy squared will be 3xy squared. All I'm doing is combining like terms, guys. And then the first is x cubed, and the last is y cubed, and there's my answer. Yeah?
Does it matter that you put the y cubed back there, really?
Okay, so that's what I was about to address. As far as how I want you to write your answers, for the sake of consistency, speed, and being able to tell you whether or not you got it right or wrong, I want you to put the x's first, but like this. It's a little bit different. Watch. So x is way before y. And alphabetically, x is before y. That's why I put x at the beginning. Okay? You don't necessarily have to do this way the way I'm showing you, but I highly suggest it so you can get organized. Okay? And then all these have x's, and all they do is descend by a power of 1. So x cubed, x squared, x. That's how I want the order to be. The y's are going ascending, and you could do it in that way too. You see what I'm saying? But
X is descending, Y is ascending.
Are we good? And then nonetheless, no matter what, for the most part, x's are always first. Okay? Alright, so enough of that. This is my final answer right here. 1 x cubed plus 3x squared y plus 3xy squared plus 1 y cubed. Okay? Now look. It is a lot of work. And if we were to do this to the power of 4 or 6 or 8, I'm not about to do that by hand. So, binomial theorem, okay, we've had rational root theorem, those fractions started from the bottom and so on and so forth. We now have something called binomial expansion. And this brilliant mathematician made your lives so much easier because he found the pattern where you would not have to ever do that by hand. But you would have to understand the pattern. Yep. So those of you who are looking at patterns, and those of you, there's a lot of us, right? That's how we learn math for the most part, by patterns. Turn your pattern glasses on, if you will, and try to find the most patterns that you see.
It's just ones all the way up on the sides.
So that's the first pattern, are the ones are on the outside.
Oh, and then it goes 1, 2, 3, 4, 5, going the next day.
So there we go. Look at this. So 1, 2, 3, 4, 5. Write this down if you need to. This will tell you what is the power. What is the exponent? So this tells you if it's to the power of 1, 2, 3, 4, or 5, it will match these numbers right here. Your second term. These are small details but important, but it's easy, okay? The second term will tell you what's the power that you're raising your binomial to. Okay? Second term tells you that. Yes, the outside are all ones. You see any other patterns?
3, 4, 5. Side 2, 3, 4, 5. Top one and the fifth one.
You add the top one. Okay, so this is the biggest pattern that you need to see, okay? Here we go. The biggest pattern is that as you're going down and the ones are on the outside, how do you get all these numbers on the inside is by this addition right here. Add those to get 2. Add these to get 6. Add these to get 5. You see what I'm saying?
But why are they so?
Okay? So they're not necessarily random. I'll tell you where they come from, okay? The first one that I just showed you was this one. This is something like x squared, which is the perfect square trinomial. It comes from a squared plus 2ab plus b squared. And our coefficients, our numbers in front, are 1, 2, 1, which is right there. Okay? You're going to see a lot. That's just one recognition, okay?
Wait, I have a question.
Hold up just real quick. This one right here is x to the 1. And this one up here is x to the 0. Because anything to the power of 0 is 1. So you know you will start here because you're going to build this triangle to answer these types of questions. You're going to quickly on the fly just go to the degree that you need to and reconstruct this table or this triangle, and it's very easy and quick to do. Okay? But like if this was x to the 1, it's a linear function. Right here you have like a y equals x, like a y equals mx plus b sort of thing happening. Okay? But I wanted to show you that perfect square trinomial right here, highlighted in green, is where it all starts as far as you can start seeing that pattern. Be like, oh, that's what we're doing. Okay? Okay, what was the question? Yeah.
How are you supposed to know, like what order your A and B is?
We'll get to that here in just a bit with our example. I want to see questions of patterns, though, for right now.
What's the sixth one? Because it shows it on there, but it's like lines up with A plus B to the fifth.
Oh, okay, so yeah, these are like off, right? This is like 0, 1, 2, 3, 4, 5, and then 6 is not shown. If 6 was shown, here we go, this is a good thing. This would be 6, this would be 15,
That would be 20,
20,
15,
6, and 1, 1. Ones are always on the outside.
Oh,
Oh, that's simple.
That's simple. There's more involved though, but yes, the first step, very, very easy. Okay? Does anyone see any other patterns right now?
1, 5, 10, 1, 5, 10,
It like
10.
mirrors.
It mirrors for sure. It's got an evenness to it. Yep. And the reason why on that mirrors is because you have 2 binomials. Okay? What was the, did you have a,
Are you looking for like one question you wanted to ask?
Oh, I know.
Yeah.
Okay, so on the third one where it's like 1, 3, 6, 10, it goes, it adds 2, then it adds 3, then adds 4. Or maybe that's just me.
no, you're right.
Yay.
So she's saying these diagonals are adding 2, then adding 3, then adding 4, and so on and so forth. You see that each jump? Yeah, for sure. So I'm keeping track of the ones who have the pattern recognition, but the one that I'm checking, that I would be very, very happy if you saw it, and I don't expect you to because we just...
got it.
Yep.
But for to the power of 2, you have your 1, 2, 1, and then to the power of 4, it's 1, 4, 6, 4, 1.
Uh-huh.
So you can multiply that second term by itself to get that, multiply that by 2 to the 6.
Well, the 4 and 2 would give you 8, though. It wouldn't give you 6. But I see where you're going with it. Hey, no, nice try. So the one that I was wanting you to see is that if it's x to the 0, how many terms? 1. If it's x to the 5th, how many terms? 6. If it's x to the 100, 101. So you always have one more term than the power. Okay? And your last one to identify, because you're going to see all this, and it is a lot to remember. That's why this is a big unit. Is this 2 to the power of n? And think n is your exponent. Okay? So let's say that I put 2 to the power of 4. 2 to the power of 4 equals 16. Guess what all those numbers add up to? 16.
Sure do.
Okay? And this is if and only if the coefficient is 1. There's a lot of applications to this, but it does take some time to see it, practice it, and some of you are kind of already wired that way. Like some of you see these patterns, and other of you, I'll be honest, I'm one that doesn't sometimes see obvious patterns. I go for these hard, crazy looking patterns that work, but the easiest ones I can't identify. I don't know, it was just weird. But yes.
Oh, I was gonna ask, so if it doesn't have, like, a coefficient of 1, then the whole has to, like, triangle, it's, like, not applicable?
So that is a huge part of it. That is a huge, huge part of it. So let me just award some points. She kind of touched on something that was pretty huge.
If it's not 1, like, it doesn't have a coefficient of 1, then you can't use
All right, so let's look at what we're talking about. Some of you are a little quiet. Make sure that you're speaking up if you have questions. The coefficients of x is 1. The coefficient of y, I know is -1, but I'm almost going to look at it the way I did sum of cubes and difference of cubes. Let SOAP take care of the signs. Okay? Now watch what I do with this, because this, right now, the biggest mistake that you'll make today, the biggest, if you don't listen and carefully watch and ask these questions that she just did, are negative mistakes. And a negative mistake could be as easy as, oh man, I put 90, it should have been -90. Or a negative mistake could make it like, I put 2 and the answer was 3,000. You see what I'm saying? So a negative mistake can change things drastically. Here we go. This is how we do it. I'm going to build a triangle of 4. Write this down with me and do it with me as I go so that you can understand the process. Step 1 is get to this power of 4. So I would say 1, 1, 1, 1, 2, 1, 1, 3, 3, 1. And just like we were saying, 1, 4, 6, 4, 1. I know this is where I'm going to stop because our second term is the power. I don't know, that feels and sounds and looks so weird. I'm like, why isn't the first one the power? Well, it doesn't make sense because the first one is the coefficient. Okay? But this 4 tells you the power that it will be. Okay? So I just found the coefficients of my 5 terms. 1, 4, 6, 4, 1. It takes about 2, sometimes 3 problems to really see what's going on. Some people can get on the first one. Okay, here we go. I'm going to look at this first term right here. X is going to be raised to the power of 4. Because that would be, had we distributed all this out, you should know by now that would have been your biggest power of x. You will never go to x to the 5th. You understand? So x to the 4th, then x cubed, 2, 1, 0. Step 3. Step 3 is to look at the other term. Okay? This one's y. And I know at the very, very far end, this y is going to be raised to the highest degree that it could be. And just like a mirror, we're going to come back
Wait, what?
That's how the FOIL, if you were to do this all by hand, that's the pattern that we're identifying. Okay?
Oh, I get it. Okay, I see it. Yeah.
Now look. This right here, now it is easy at first glance. It really is. But there's a lot of, well, what if it's this? Or what if it's this is different? Or what if it's this is different? And it throws a lot off. So what I'm trying to show you are shortcuts that work for quote unquote the easier ones. Okay? Sophia got a lot of points because the coefficient being 1, and more so the coefficient being positive, are when these shortcuts work, of what I just said. Okay? Here we go. If this sign right here in green, that's not green, but if this sign right here is a subtraction, then it'll alternate. So positive, negative will alternate positive, negative, positive, negative, positive. Always starting with positive. It almost felt like soap.
Wait, hold on. You gotta get
Okay? My binomial was a positive x, negative y. So it will alternate positive, negative, positive, negative, positive, negative throughout. You with me? Yeah.
So if it's a negative and then a positive, then it alternates the opposite way.
Let's get there. Let's get there. We gotta develop it because there's a lot of different variations. It's not quick and easy, and I know you want that answer right now. Let's get there, okay?
So if and you no matter like just completely disregarding the outside side, like if it's inside though, would you go soap?
Yeah. Let's wait. You guys, I think, are asking the same questions. Let's wait till we get there, okay? Here we go. This wasn't needed. This wasn't needed. But I wrote it anyway so I can make sure I got everything. You with me? What's anything to the 0? 1. So those are just 1. So your first term is x to the 4th. Here's another pattern right now that I will help you out with. Your power was 4 originally. If you do this right, these, well, maybe I shouldn't have used purple because one of them's purple. These will add up to 4. Just to make sure that you've accounted for everything. That used to help me because I would mess up sometimes. I put like 1 and 2 and not realize, ooh, I did something wrong because they should have been 4 added up together. Yes, it always works. And it works in stats as well with other things that binomial CDF and just stuff. Okay? So, here we go. What would we write for that? Minus 4x cubed y. Okay? Plus 6x squared y squared. Notice the parentheses are gone. This is fully simplified, okay? And yes, it gets more involved, but let's walk first. This is going to be minus 4xy cubed and plus, anyone? Y to the 4th. And that's it, all by itself. This is it. So you just saved yourself, guys. This is to the power of 4. That's a lot of algebra that you just saved a lot of just knowing the pattern. Okay? Yes?
So you said if the exponents would add up to 4, but like if it was like to the power of 3, would they add up to 3?
Yep.
Or is that-
If it was to the power of 8, they would add up to 8.
If we put x to the 0 or y to the
If you put x to the 0 or y to the 0, I won't count off, but you need to get used to not putting it because, like, as you get older, there's things that you just don't write. You know what I mean? Like, whenever I say, what's 2 plus 2, what do you say?
4.0.
Exactly right. You don't say 4.000 or 4. Or you don't say this 4.0/1. You know what I mean? There's just, and I'm not making fun of it. I'm just saying there's things that you don't write. Okay, so just know that. Okay. 4.0/1. All right. So let's do expand this one. Okay, so it's already different. All of these are subtly different, but drastically on their answer. Okay, here we go. First step, I see the cube, So 1, 1, 1, 1, 2, 1. I will stop when the second term is 3. That is step 1. So let's write these coefficients, these primary coefficients, and it's about to get involved. Okay, yes? You don't have to memorize it, but build it. You know how to build this, right? Like the thing that I would say to memorize is that right there. Because once you know that, then you can add these two, keep the ones on the outside. Add these two, keep the ones on the outside.
It is appearance.
Cool? All right, here we go. Our first term is still a positive, but it's not just one letter or one number. It's still one term because it's 2a. So we have to, this is why I put parentheses on the other one. We have to put parentheses to the third power. Okay? This, write it in your notes. Don't just stare at me smiling, looking pretty. Please understand that this is not the same, okay, as 2a cubed. Those are not the same. This would be like if you applied 3 to both little pieces. Like 2 to the power of 3 and a to the power of 3. Do you see that? Okay. So let's keep going with this. Well, I'll come back to that in here in just a bit. But it's 2a squared, 2a to the 1, and 2a to the 0, which ultimately we will not end up writing. And this is why I don't want you to write it cold, because when you have more than just one item raised to the 0, it's cleaner just to one it out. All right, here we go. Starting from the other side, we have the b. Technically, I don't need parentheses because it's just one term. You with me? But I'm going to use parentheses on this to help you not forget this rule right here. Okay? Here we go. So it'll be b cubed, b squared, b to the first, b to the 0. We learned last problem that if it was a positive negative, essentially, if there was a negative right here, that it would alternate. It would be positive, negative, if there was a negative right here. What we should have, and we did, look at were both of them. Because the other one had positive, negative. So this one has positive, positive. Obviously, if that's all you have, all of them will be positive. Okay? So positive, positive, positive. Okay? Here we go. If I asked you, what is your coefficient? It's not just 1 anymore. Get all your numbers together, and you get 2 cubed times 1 would give you 8. You with me? So look, this was positive, this was positive. Yeah, if this middle one is positive, they're all positives. If it's negative, then they alternate. Okay?
So what if it's a negative next to the coefficient?
You'll see that. You'll see. We're not there yet. Okay?
The coefficients like the 1, 2, 3, and 1 all add up to 8, so is that just a coincidence, or is that like a...
No, remember that thing that I showed you that it was 2 to the power of n?
Oh, yeah.
So n is 3. So these will add up to 8. And it's just a coincidence that this was 8. But you'll see in a bit, those coefficients are no longer 1, 3, 3, 1. Yeah.
What if the first sign was negative and then the
Okay, so there's 3 people that have not asked that question. And we're going to get to that. Those are the more involved ones. Let's wait on that, okay? What we've learned so far is just positive, negative, alternates. Positive, positive are all positive. Write that in your notes because you won't remember it. Trust me. Okay? It's hard for me to even remember stuff that subtle, okay? Please write it in your notes.
two negatives, will they all be negative?
We'll get to that. We'll get to that. Okay, here we go. So now I have a cubed and b to the 0. We're going to 1 out. We're not going to write b to the 0. There's my first term. Okay, here we go. It will add, and add. And I'm color coordinating this, guys. Yes, it was much more difficult in my day because you couldn't group stuff like that. It was all black and white, and I'm like, wait, where did you get that number? So this was, all my coefficients are together now. And what do I have? 12. 12 a squared b. What's my next coefficient? 6 ab squared. Those are not the same. A squared b is not ab squared. So you can't add those and say 18. You know what I mean? So good stuff so far. And then now, it's just b cubed. This, and notice that 1331, it's gone. It's no longer there. Why? Because of the coefficient not being 1. We'll get to those negative coefficients that you'll keep asking about, okay? All we've done is positive, positive, or positive, negative. All right. Here we go. X minus 4 to the power of 5. We're going to first build our triangle all the way to 6 terms, or all the way to where the second term is 5. So 1, 1, 1, 2, 1, 1, 3, 3, 1. Y'all help me out. 1, 4, 6, 4, 1. Good. Because remember, you're just adding those diagonal pieces to get that next one. And this is where I stop. Because my second term, the coefficient is 5. Okay? And you may get some to 7, 6 or 7 on the test. All it is organizing parentheses and negatives. That's it. So here we go. So we have 1, 5, 10, 10, 5, 1 is where we start. Okay, I'm going to already ask you some stuff. All I see is a minus. What will it do? It'll alternate starting with positive, okay? So to be a positive, negative, positive, negative, positive, negative.
So it's always going to be that way?
Yep. For this particular one, yes. Okay? We'll wait till we get there, okay? Here we go. What will the first term be raised to? The 5. What will the second term be raised to? 0. Because those powers will add to get 5. I'm just trying to do it different ways, guys, not the same way over and over, and see if you can overlap the patterns, okay?
So do not put it in as a negative form?
So, and that's what I'm talking about. I'm not, right now, with what we've learned, I'm not putting it as a negative form. The easier route for me, from experience with students, not me particular, but for you guys, is the plus plus or all plus. The positive negative will become plus minus, plus minus, alternating starting with plus. Don't worry about the sign other than that. I'll show you when to worry about the sign here in just a bit. Okay? Here we go. So it'd be x to the 4th, x to the 3rd, x squared. Guys, do I even need parentheses on these x's? No, because
It's just one.
it's just one variable. Okay? If it was 2x, it's still one term, but it's not a coefficient of 1. Okay, here we go. Again, I'm not going to look at this as a negative. It'll be 4 to the 1 squared cubed to the 4th and to the 5th. Okay? What will the first one be?
X to the fifth.
X to the 5th. That is a common mistake that was just made. 4x to the 5th is common. That's why I like to write 4 to the 0 as what? 1. So that I don't mistakenly say 4x to the 5th. Okay? She's not alone. I've done that too. Okay? So x to the 5th. Careful. Minus 20. X to the 4th. Okay? Don't rush yourself. Make sure it's right before you just blurt out the answer. 160, right? Because 4 squared is 16. Because all these coefficients, they're no longer just in front. That was Pascal's triangle building that. So you have 16 and 10. 64, that's negative 640. Go with me? 4 to the power of 4 is 16 squared, which is 256, that we're going to multiply with this 5. What is it, 1280? Okay, so 1280x. Yes, we're going to have to do multiplication from 3rd grade. My youngest son's doing it right now. 28 to 12, because you won't have a calculator for these kind of problems. Because then you could easily just put expand, done. That's why you can't have a calculator for these problems. Okay, and I'll show you how to do that so you can check your homework here in just a bit. Okay, and then the last one is 1024. Okay. 1024. All of this is my answer. Yeah, this could be an 8-point problem. Okay, so it's not something like you just want to, I'll just not do that.
So how'd you do that? So you did,
I did the coefficients, then the descending powers with parentheses, took care of the signs, and simplified.
so it was like you did x5. So you did 5x squared. Oh, okay, I get it.
Okay, let's keep going because they get more involved. I'll tell you as hard as they get. The hardest one that they get to is the ones that people are already asking about. Those two, no, not yet. So,
Can we just move ourselves?
you can if you want. Just go ahead and start. I will still work it. Just don't look up here until you're ready to look at your answer. But everyone else, I'm going to talk you through it. So it's 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1. And we're going all the way to 6. So 1, 5, 10, 10, 5, 1. And finally 1, 6, 15, 20, 15, 6, 1. This is where we're stopping. Because the second term will be the power where you stop. Okay? Now look. All I want, and some of you are working hard right now, and I appreciate the eagerness. And you're going to town right now. A lot of you have your heads down, and you are going to town working the problem out. But you might be doing way too much work because you didn't read the question. You got in autopilot mode a little bit, and you just went off on the other ones that we did. And this is different. All it wants is the 4th term. That means there's a systematic way to do this. Trust me, you don't have time to do the whole thing. You don't. Okay? The 4th term is that one right there. Okay, but that 20 is not the answer.
I found it.
Okay, here we go. Here, let's 20 is your starting coefficient. Watch this next part. We still have to start from 6, and it's like 6, 5, 4, 3, 2, 1, 0, and start the other way, 6, 5, 4, 3, 2, 1, 0. We're going to do the one that has 3 and 3 as their powers. That's why I wanted you to look up, because it is different.
Wait, I'm sorry, where'd you get those, like, numbers of the
So these are like x to the 6th, x to the 5th, x to the 4th, you know what I mean? Just like we did on all the other 3 examples. Yes, Sophia?
If it said to find the fourth term of like x plus y, if
I-
it didn't have like 3x plus 2y, it was just x plus y. Like,
You're saying without the three and the two, and then if there's no coefficient.
So listen, this was her question. Listen. Shh. She said if it said find the first or find the fourth term, but this 3 wasn't here and this 2 wasn't here, would the answer be 20? It would not. The coefficient would be 20, which is your next question. But the term is the whole thing just multiplied, glued together. So this is one term. Because you still have stuff to the left and you still have stuff to the right. You with me? Alright, so here we go. What will go into this first set of parentheses? 3x. Now, look at the signs. We've already talked about this. Look at the signs. We know they're all going to be what? Positive. So down here, I could, if I wanted to, show all of these positives. You see what I'm saying? So that if it was a negative in front of this, I would know what I was about to do. Okay? So here we go. We know it's going to be a positive. Because of that, they're all positive. You said your first term is 3x. Second term is 2y. Now there's a lot about to happen. For the sake of speed and time, I'll let you use your calculator just to see what that times this times that, which is 27 times 6 times 20. What do you get? 4320? Say again? 2 cubed is 8. Or did I say 6? Oh.
Ooh, that's
So 2 cubed is 8.
I thought the same thing. I was like,
3 cubed is 27. And then multiplied by 20. Alright, here we go. You tell me, how many x's do I have? 3, so x cubed. Guys, it gets more involved than this, so please make sure that you're watching, because I have a difficult one for you at the end. And to me, it's the only one that's difficult.
That's you, Mr. Gomez.
For you, not for me. So y would be what? Third. So that entire thing is your fourth term.
That's it? That's the answer?
That's it.
That was simple, Mr. Gomez.
Okay. Here we go.
Okay, what is example 5? I better not confused.
Example 5 to me is as difficult as they will get on the test. But the one that I'm going to show you could possibly be a bonus question
Not gonna work out.
on the test?
in life. Here we go. So the coefficient, I can't tell you what's on the test. But anyway,
It's all
so
Test, guys.
to the power of 4, listen, is 1, 1, 1, 1, 2, 1, 1, 3, 3, 1. Stop at 4. Okay, so there's our power. Can you imagine, guys, really think back. All the little things that I told you, and I said this at the beginning of this unit, said there's a lot of lower level to medium things to memorize. In the grand scheme, there's only a couple things that are difficult that you're learning. Those were the days that I touched on. And I even told you what days were difficult. Other than that, these are kind of basic skills, but there's so many of them. You have to practice this. This isn't something that you're going to be, oh, yeah, I'll cram that the night before. I hope that you don't just study the night before. I really hope that you don't. Okay, here we go. So our coefficient is 4. Okay, here we go. This is minus. The first one is a positive. We know that alternates. Positive, negative, positive, negative, positive. We want the coefficient, though, of this term. We have to find this term now. You with me? We know the first one is p to the 4th, then p cubed. There it is. You see what I did there? So it's not 4 actually.
It's 6. It's negative 6.
I think I wrote 4 because I was thinking of where it stopped as far as my power, and that was my bad, my mistake. But p squared will be a positive, negative. This is a positive. So it's a positive 6. Okay? And I really hope you don't put 6 as your answer because you're not done. Because it was all about if your coefficient wasn't 1, you were going to work. It wasn't easy. So this is to the power of what? 2. This is to the power of 2. And you can verify because those two will add up to get 4. So you're good. And your term is 5p. You already know it's positive. Your other term is q. You with me? And now you're just going to simplify everything out. So you have, don't put the negative. Don't put the negative in that q. Don't. Okay? The way I'm showing you, I would prefer you not to. I would prefer you just to remember alternating. The ones that I'm about to show you, then worry about the negative. Okay? So 5 squared is 25. 150 is your answer. I didn't say what was the term. Said what was the coefficient. So if you over answer, you would get that wrong as well. Alright, so now let's go to the difficult ones, okay? I have 2 difficult ones for you and then we'll call it a day. One's with 2 negatives and the other one has square pieces in it. Here we go. Let's say we have negative x minus y. Now, off to the side, if you had negative x plus y, you could make this easy. Simply by flipping what order you were adding, and then do it like normal. Okay? But if you have one that has 2 negatives, which is this is the first one that we've had that has 2 negatives, these are going to require some work. There are no more patterns of alternating positive negatives, or all positives. Okay? And don't just assume that they're all negative. Okay? Yes?
So on that one, would you still want us to put the x first, like when we write it?
That's a very good question. This one, if you switch it around, you do not have to put the x first. Okay? And in the grand scheme of things, you really don't have to put the x first. It's just going back to what's kosher, what's more common as you go higher. You know what I mean? You just see people in your classes, they do it that way too because that's just the way you were taught. You don't say y equals b plus mx. You were taught mx plus b, and that's just the way you were taught. You know what I'm saying? Yes?
So you can put like.
You could put y's first and then x's at the end. Yeah.
Well, would it matter if you? It would still matter if you did like x's in descending and y's in descending.
It would be the same. Y's would be descending.
Okay.
X's would be descending from the right.
Okay.
Nice questions.
Can that be said for like all equations?
Mhm.
Okay.
All. Here we go. Because it was all about signs on this. I'm wanting you to concentrate on signs right now. Here we go. So let's say that this is, because we would just follow that out. Let's say that this was to the power of 3. 1, 1, 1, 1, 2, 1, 1, 3, 3, 1. We stop here at 1, 3, 3, and then 1. Now, guys, again, we're talking about these negatives. So this goes to what like 3 or 4 of you were asking, what do we do here? The first term is a negative x. It'll be cubed, negative x squared, negative x to the power of 1, and negative x to the power of 0. You with me? The other term is going to be a negative y to the 0, negative y squared, negative y to the third, and negative y to the fourth. We are adding.
Wait, you did the one. You did y squared instead of y.
Oh, my bad. Nice. So that was my bad. Let me go back. I skipped 1. So this should be 1 right here. Nice catch, guys. So this is 1. This is squared. This is cubed. This is our first minus minus. Look, don't let this confuse you. Preemptively, at first glance, you're going to add these. And whatever these signs come out as, that's what they're going to equal. Watch.
Wait, are they all supposed to be pluses?
Here we go. Yep, they're all pluses right now. So now we're going to look at negative x cubed is a negative. What's negative y to the 0? 1. Not negative 1, not 0, but a positive 1.
So it's always been a positive one?
Wait, what?
Is there ever going to be a case where it's not positive one?
No, anything to the power of 0 is a 1. So it's like, yeah, regular 1. It's almost like it's not even there. Okay? Here we go. Watch up here, please. So what sign will this become? Positive. And you're going to multiply it with this sign. Negative. And you're going to add that negative. So it's just subtraction. Okay? You with me? So it will become 3x squared y. Okay, let's look at the next one. We have my x's positive or negative? Negative. Positive or negative on the y's? Positive. So right now, a negative times a positive is a negative. So it's adding a negative, so we're going to subtract. You with me? And it will be, hold on real quick, it will be that. Okay? Yes?
Why did you square the 3?
Because the 3 wasn't in parentheses. You see what I'm saying? The 3 was the coefficient. We're going to do one in just a bit where we will have to square the 3, and I'll make it a small cubic one. Okay? Yeah, just the last one after this. But what's my last sign going to be? A negative y cubed. See, this wasn't that bad. Keep track of negatives and keep track of parentheses. Now I'm going to do one that's difficult now. In my opinion, one of the most difficult ones. Yeah. Okay, here we go. Yep.
Why can't you just, why do we have to do it so that, the negative y is in the parentheses and it's not like, it's all positive?
Because I said on the first 3 or 4 examples that we did, if it's positive, positive, everything's positive.
Yeah,
If it's positive, negative, it will alternate.
yeah.
Anything other than that, put it in the parentheses. Exactly of the sign. And I'm going to show you one more like that right now, okay? Here we go. So we have, let's put it as negative x minus 2y squared. This is as difficult as you'll see it. Okay? Here we go. 1, 1, 1, 1, 2, 1, 1, 3, 3, 1. We stop at 3. Okay? The first part, negative x, is going to the b to the... And guys, the way we're doing this, you could do every single one of them like this. I just like to give you that shortcut of all positives or positive negatives. Okay? But if you want to do more work and do this every single time, then go for it, whether it's positive or negative. And it will be 3, 2, 1, 0. In parentheses, 3, 2, 1, 0. Preemptively, they're all adding. To make things look easier, I'm going to do it right now. I'm going to erase those things that are to the power of what? 0. And I'm also going to erase anything that has a 1. So here goes this 1. Next, here goes this 0 power, because that's 1. This is 1 over here, because it's raised to the power of 0. And finally, that 1. If that helps you, because it would help me, I would do that, so that I'm looking at a lot less. And it looks like a lot less. Okay? Here we go. Positive or negative x cubed? Negative. Now look, right here I'm going to do it a little bit a different way, but the same that we've been doing. I have a negative squared, turns positive. I have a negative to the first, which is negative. And I have this guy right here. So the whole thing is going to be a what? Negative. Now I just got to group my things together. Okay? And if you didn't see it, please watch the video because I need to finish it before we have like 3 or 2 minutes left. What will be my number? 6. Okay? X to the second. Y to the y to the second, guys. Y to the second. Because it's y to the second to the first power. I know, this is nasty. Alright, so look. Let's look at this. Negative. Negative. Negative or positive? Negative. Okay, here we go. Keep track. Negative or positive? Positive. So right now, it's negative multiplied together. So with this final one here, it will be a negative. Now let's keep track. Careful. Look at it carefully. What will be my coefficient? 12. Because it's 2 squared to give you 4, multiplied by that 3 to give you 12.
Wait, are you squaring from the square?
Yeah, everything in parentheses is squared. Everything in parentheses is squared. So how many x's will I have? 1. Careful. How many y's would I have? 4. Did you add or multiply? Multiply. A power raised to a power, you multiply. And the way, we already saw that. We already saw that, didn't we? If you have like x squared, x cubed, this is x to the 5th. If you have x squared to the 3rd, this is x to the 6th. Power raised to a power, you multiply. Now the last one, positive or negative? It'll be negative. 2 to the 3rd is 8. Y squared to the 3rd? Y to the 6th. Done. Nice job today, guys. Cool?